Hi, in this set of videos we're going to solve two problems about project management topic that we learned earlier. Specifically, we're going to solve two problems about scheduling. All right, so the first problem entails drawing the project network diagram and then finding the critical path, finding the early start, early finish, late start, late finish of the activities, which will allow us then to find the slack of each activity. And then we will finish this problem by finding out what would happen when an activity is delayed by a certain time. And the second problem is about probabilistic time. So we will have a set of activities, a project network diagram given to us, and then we want to find what's the probability to finish the project within a certain time. So hopefully these videos we're going to reinforce what you have learned in the previous set of videos that were posted, and it will give you a good opportunity to practice on your own. So let's start. So this is our first problem. We are given a precedence relationship table and the duration of the activities. Just a quick reminder, what do we mean by a precedence relationship activity? So you can notice here that for every activity, all right, we are given an immediate predecessor. Remember, this is what a precedence relationship table is all about, because we know that in a project, especially when we draw the P&D, we can see that an activity has so many activities coming before it, but that does not mean that all of these are called the immediate predecessor. Immediate predecessor, as the name implies, okay, we have the term immediate. It's the activity that comes immediately before that activity. Okay, so let me take an example here. Activity C has an immediate predecessor A. All right, now we can see later, for example, in one path, that activity H, one of its predecessor is C. Here we did not list also A, right? Even though we know that A is coming before H because it's coming before C, which comes before H. But we are not listing it as an immediate predecessor because it's not immediately completed before H. Okay, so I just wanted to remind you of that. And then, so our first step is going to build a PND, project network diagram. So let's do it. Okay, so to build the PND, I have posted the table, the precedence relationship table on the right hand side so that you can see it as we are building the PND. So let's start. As we learned that we build the PND one activity at a time, and we look at the precedence relationship table, right, which is here. So we go from the top. So activity A, it has no precedence relationship, so I can put it anywhere, right, as we learned before. Activity B has also no precedence, no immediate predecessor. That means it can start immediately, which means A and B can start at the same time. Now activity C has A as its immediate predecessor. What does it mean? That means A should be completed before C can start. So I have to show that. I have to show the relationship between A and C with the arrow that I'm showing here, right? And it's not by coincidence that I'm showing C here on the right hand side of A, because obviously it's going to start after A is completed. Okay, and we agreed before that from left, the time axis goes from left to right. Okay, now activity D also has only activity A as its predecessor. So here we go, which means D and C, because they are not related, they can happen at the same time. Activity E has also A as its predecessor. So here we go. Activity F has a predecessor, which is E. So here we go. Remember, always you have to show the relationship with the arrow. And remember that we are using the activity on node convention, right? There's another convention called the activity on arrow, but we are not using it. In our case, activity on node, where the activities are inside the nodes, inside these circles, and the relationship is depicted through that arrow. Now, activity G has two immediate predecessors, which are D and F. So I will show G here, and I show two arrows, one coming from D and the other coming from F. Activity E has also two immediate predecessors, B and C. So here we go. And finally, activity I has also two predecessors, G and H. And here we go. All right, so these are now all the activities that are listed in the table. But again, as we discussed earlier, it's always recommended to have one unique starting activity. So that's why I'm going to create a virtual activity or a dummy activity. Okay, it's virtual, does not happen in real life. But I just wanted to make my diagram look as starting from one unique starting node. And you'll see later that in the calculations, I'm going to give that virtual node S, everything will be 0, right? So it has 0 resources, it will take 0 time to be completed, so it has no effect at all on my schedule. All right, now we want to find the critical path. To find the critical path, we want to list all the paths. Also, as I advised you before, that it's better not to miss any path, to do it systematically, to scan your PND systematically. So what I want to do, I will scan my PND from top to bottom. Okay, so what do I mean by that? I will start, of course, any path start with the starting node. Now, so I will go like that, S, B, H, and I, and here we go. Then the second path is going to be, so going to B is done because from B I cannot go any different path other than the H. So now I have to go down SA, but I will go up because remember I'm scanning from top to bottom. So SACHI, and here we go. Before that I missed to do this. I need also to find the duration of each path while I'm listing them. Okay, so the first path, how do I find the duration? Here we go. The duration is the summation of the duration of the activities in that path. Now S has zero duration because it's virtual. So what I'm doing here, I'm adding up the durations of the activities B, H, and I. Where do I get these? I get them here. So B is 6. Then we have H, which is 12, and I, which is 2. Summing them up, we get 20. Now the second path, as I showed you, SACHI, now its duration. The duration comes from A, so it's 5. And then we have C, so plus 4, 9. Then we have H, 9 plus 12, that's 21. And then we have 2, and that's 23. Okay, now the third path, SA, now going up, we have already exhausted these paths, so we go here, SADGI, all right, here we go. Also, we sum up the durations of these activities. I don't need to do it again. I will show it to you here. And finally, the last path, which is the one on the bottom of our PND. Here we go, and it has that duration. So now we have built the PND. We know how does our project look like, and this PND allowed us to find all the paths and finding each path allowed us then to find its duration. So we found that the path has a duration of 20 for the first path, 23, 24, and 26. Obviously, 26 is the longest. Remember, I asked you to do that. So we put that asterisk on the right-hand side of the duration just to denote that this path is our critical path. All right, so this is our critical path, and this is very important. Why is that? Because we know that the critical path is the duration of the critical path is the duration of the project. So now we know that the duration of our project is 26. Okay, so let's go ahead and answer more questions.